In this demonstration, I will be creating a sheet metal component typical to the automotive industry. This part shall be designed in context to provide mounting for a piece of equipment and relate it to surrounding geometry that provide mounting fixture points. The Part Properties tab in Sheet Metal Preferences provides a broad set of options to ensure the flat pattern provides the right output for manufacture. With parameter entry, a number of bend definition methods are available, with definition of flat pattern allowances by a neutral factor constant, customizable formula for bend allowance and bend deduction, together with the standard DIN 6935 method. In addition to the neutral factor bend table, we have separate tables for bend allowance and bend deduction. When configured, the material selection method has the ability to drive a number of configurable tables. Each parameter in the material table can be a constant value or read from a lookup table or formula. This example is using lookup tables that define the bend radius and neutral factors based on the material thickness and bend angle. A punch and die are selected as the default setting for this part. Physical material properties can also automatically be applied. We'll start by creating a tab using a predefined sketch. And then add a flange using the match face method with an offset. Now we'll add a mounting hole for the fixing. This fixing needs to be recessed, so we'll add a dimple feature to complete this fixture point. Now that's complete, we'll move to the other fixture point and create another base tab, this time using the Region Boundary Curves selection filter, showing the creation of a tab with multiple loops. Next we'll use the same selection method to create the main tab, and you can see multiple regions are picked up from different sketches to create the final desired profile. To join separate bodies together, we'll use the bridge bend command. Using the fold transition type with a full start edge, and you can see bend parameters can be defined by length or bend radius. A number of material conditions can be selected depending on the desired end result. Let's do the same at the other end, where we can see bridge bend will operate on a disconnected and intersecting bodies. The advanced application provides access to previously aerospace specific commands such as lightning cutout, used here to provide a cable access aperture. Now our part needs some strengthening features, starting with a simple bead and now an advanced flange around the outer edge, noting we can use path selection to control the limits of the feature. Next, we'll add some strengthening to the bends near the fixing attachment points, flattening the part using unbend where needed and creating bead features. Note that these can be created either in the flat or in the form state, depending on the requirement. When created in the form state, the feature washes out through the bend. Now to add some fixing holes for mounting the equipment, and finally add some break corner features to remove the sharp edges. Note that this can be done easily with rectangle select rather than single selecting small edges. Now to create the flat pattern using the orientation by CSIS method to ensure the flat pattern rotation is appropriate. Once created, we can view the flat pattern alongside the part in a separate window. The bend sequence IDs can be adjusted to suit the bend order needed for manufacture. On completion of the flat pattern, we have some basic attribute data that tells us the interior and exterior cut lengths, along with the minimum blank size, and this gives us the data for some basic cost estimation. This part is intended to be laser cut, and small holes are not appropriate for this method, so we can replace holes of a certain size with centre marks. Here we are using an expression to replace all the holes equal to or smaller than twice the material thickness with centre marks. Now the part is complete, we can analyse the design using the out-of-the-box visual reports to display sheet metal parameter information. Let's take a look at the bend angle report. And finally the face type report that shows us feature types to further assist in understanding the part geometry.